So we are going to continue our journey into completing the square. So what we've noticed from our previous examples is that the leading coefficient was always 1. We're going to extend our learning just a little bit to now include when the leading coefficient in front of the x squared is not 1. So remember that we're dealing with an equation. As long as an operation is applied to one side of the equation, we can apply it to the other side of the equation, and equality still is maintained. So perhaps I'm going to take a look at my first example right here. If we notice, there is a leading coefficient of 2 in front of the x squared. I'm going to ask myself, is there any operation that I can do to make that leading coefficient to be 1? And the answer is yes. There's actually 2 that I can think of. I can divide both sides of the equation by 2, or I can multiply both sides of the equation by 1/2. Either will work. So I'm just going to rewrite my equation here, and so my x's are isolated, so that's good. So my x's are already isolated. So now I'm just going to divide both sides of the equation by 2. And when I do that, the left-hand side changes to x squared minus 4x is equal to 5. So I'm just going to say divide both sides by 2. And in essence, generally, I want to isolate x's to one side. And which actually occurred in that first step. And I'm going to make leading coefficient one. So I did that by dividing by 2. So believe it or not, I've solved this equation before. So I'm just going to complete the square on this step. So complete the square. And I do that by taking this middle term. So negative 4 divided by 2, and I'm going to square that. So that's negative 2 squared, and that is really just 4. So I add 4 to both sides of the equation. Now I take a look to the left-hand side. I am going to factor it. If I factor the left-hand side, I'm going to add the right-hand side. So really, I'm just going to factor left-hand side. So this brings us back to what we've already taken. The next step is I'm going to take the square root of both sides. Square root of 9 is 3. So I can get x is equal to, I'm going to add 2 to both sides. There. If you want, I can continue my annotation. So here, I factored the left-hand side. Here, I square root both sides. In the next step, I really did nothing but simplify. And the right, I isolated the x. So, and my solutions are simply going to be 2 minus 3 will yield negative 1. 2 plus 3, 5. So those are my solutions. Now, things aren't so nice in this next example. But you won't be able to spot it out often. So what I'm going to do is I'm just going to go about completing the square. So I'm going to isolate the x's. So here we are. I isolate the x's. Now I'm going to complete this square. But hold on. if you notice, my leading coefficient is not 1. So I'm going to divide both sides by 3. So when I divide the left-hand side by 3, so I'm going to make leading coefficient 1. And that's what it's going to look like. Now this is not going to be very nice at all. Maybe we don't really know why. The next step I'm going to do is I'm going to complete the square. Now, maybe some of us already are feeling a little bit anxious because there's a fraction there. So I'm going to complete the square. So take that middle term 2 and I divide that by 2 and I square that. 2 divided by 2 is 1 squared. And so really I'm just going to add 1 to both sides. I'm going to factor the left-hand side, so that's x plus 1 squared. And the right-hand side, negative 1/3 plus 1, is going to be 2/3 because 1 is 3/3. So negative 1 plus 3/3 is 2/3. I'm going to take the square root of both sides. Consider both positive and negative roots. And now I'm going to subtract 1 to both sides. Fair enough. So this is a logical place to stop. However, sometimes we like to rationalize our denominators. Now, it's going to get this is where it gets tricky. So how do I make it so that they have the same denominator? Well, allow me to rationalize the denominator 2 over root 3. So I'm just going to write this as plus or minus as a root of 2 over the root of 3. Now, to rationalize it, I'm going to multiply it by root 3 over root 3. So I have x is equal to negative 1 plus or minus. I'm going to multiply the numerators, so that would be root 6 over 3. I swear we're almost done. So this would be x is equal to negative 1 plus or minus root 6 over 3. But to combine these, I need a common denominator. So this would be x. So I'm just going to both put these over 3. So there's my final answer. My whole purpose for you here was, in this step, you may think, oh, I got the right answer. And for the most part, I would consider you are correct. However, in the answer key, it may look like this. Well, which one is more correct? Well, the pink one is more correct and is the mathematical standard that we write solutions. The yellow one you'll get full marks for, but they are the same solutions. It is very difficult to identify that they are the same. All right. Solving by completing the square. Leading coefficient is negative. Fair enough. It's a different thing. But I'm just going to start off with my equation. I'm going to ask myself, well, that leading coefficient is not 1. It's actually negative 1. Is there a way that I can make it positive? I'm going to say absolutely. And that would be to multiply both sides by negative 1. And when you multiply both sides by negative 1, this would be x squared minus 6x plus 2 is equal to 0. So now you have an equation that's equivalent to the original, but in a much nicer form. So feel free to solve that. Now this next one is really, really kind of nasty. Again, we have to ask ourselves, how can I make this leading coefficient, which is negative 3, a 1? Well, I would probably start off by writing my equation, and then I would divide both sides of my equation by negative 3. What is so incredibly nice about having 0 on the right-hand side is 0 divided by any number other than 0, or 0 times any number, is going to yield 0. So the right-hand side is equal to 0. The left-hand side will just yield x squared minus 5x over 3 plus 4 over 3. Now, this will be incredibly tough to complete the square. So many fractions everywhere. But I believe in you. You can do it. So if we just simply review what we've done. Now, we've done a lot, actually. Really, we are at our best when that coefficient, leading coefficient, is 1. Then we complete the square. If it's not 1, like this, make it 1. How? By applying the same mathematical operation to both sides. Last but not least, if it's negative, don't sweat it. Just simply do what you do and make it 1 by generally multiplying or dividing by a negative number.